So I want to go over the first test with you. Number one, we were supposed to find slope-intercept form of the equation of the line that passes through these 2 points. So what we're going to do is we're going to start with point-slope form, and then we'll turn that into slope-intercept form. So what we need for point-slope form is a slope and a point. Well, we've got 2 points, so we're good there, but we do need a slope. So we'll calculate the slope from these 2 points using our formula. So let's see, we're going to have y sub 2 minus y sub 1. That's going to be 6 minus negative 3 over x sub 2 minus x sub 1, which is 2 minus 1. And you're going to get 9 over 1, or just 9. So our slope is going to be 9. It's going to go right here. And we can use either point that we want. I guess I'll use this one. So y minus y sub 1 is going to be 6. Our slope is 9. X minus x sub 1 would be 2. And that's the equation of the line in point-slope form, but we want slope-intercept form, so I'm going to distribute and then add 6 to both sides. So y minus 6 is equal to 9x minus 18. And then we're going to add 6 to both sides. And you get y is equal to 9x minus 12. And so this is what we would have for slope-intercept form, our y equals mx plus b form. Number 2, we're just, let's see, can you see this far over? Number 2, we have a function given. And it's the absolute value of 2x minus 1 minus 10. Okay? So, and what we want to find is f of negative 2. So, in other words, we're going to be inputting into this function a negative 2. The x value is going to take on negative 2. So everywhere there's an x, I'm going to put a negative 2. So instead of 2x minus 1, it's 2 times negative 2 minus 1. So now I just need to work this out. So in the absolute value bars, you get a negative 4 minus 1. So it's the absolute value of negative 5. And the absolute value of negative 5 would be 5. And 5 minus 10 would be negative 5. So if we input a negative 2, the output that we get is negative 5. So f of negative 2 is equal to negative 5. Now on the third problem, we're going to use interval notation to show the domain of this function. So we've got the function f of x is equal to square root of x minus 7. Now, the domain is limited here because we can't have a negative under the radical. So in other words, x minus 7 has got to be, non-negative. Well, one way you can say that is x minus 7 has got to be greater than or equal to 0. So we can solve this by adding 7 to both sides, and you find that x has to be greater than or equal to 7. So the acceptable values for the domain here are going to be any value greater than or equal to 7. So using interval notation, that's saying we can have 7 all the way up to infinity. Those are the values that can go into that function. If you put any value in that's not in that interval, you'll get a negative underneath the radical. Number 4 was asking whether or not this is an odd, even, or neither. So, got this function 3x to the 4th plus 5x to the 2nd. And I can tell you that when one is even, when a function is even, then f of negative x will still just equal f of x. So if we were to input into this negative x, you would have 3 times negative x to the 4th plus 5 times negative x to the 2nd. But when you raise a negative to an even power, you're going to get a positive. So in other words, this still just works out to be 3x to the 4th, because the negative to the 4th power becomes a positive. Likewise, a negative to the 2nd power becomes positive. So you're going to get just 5x squared again. So when we inputted the opposite of x here, we still got the same result as the original function. So this is an even function. Even function. Number 5, we were adding 2 functions together. So, let's see, we're doing f of x is x squared plus 7. G of x is 2x plus 3. And f plus g of x just means f of x plus g of x. In other words, we're going to take x squared plus 7 and add 2x plus 3 to it. So we're just combining like terms, and the only like terms we have are the 7 and the 3. So the answer would be x squared plus 2x plus 10. Just adding the functions together. 6, we were looking to identify the parent function and then explain the sequence of transformations that would lead from that parent function to the function you're given here. So the parent function, well, first of all, the function that you're given is this one. And this is the parent function here is the cubic function. But it's got some things going on that have transformed it, that have moved it around and stretched it. So one thing you notice is this x minus 5, this tells you that there's been a shift 5 units right. Sort of the opposite of what you would think. It's subtract there, so you kind of think it's going left, it's actually going right. And this, adding a constant on out here, tells you there's going to be a shift up of 3 units. And this right here, the fact that it's a 2 there means there's been a stretching by a factor of 2, and the fact that it is a negative means that it's been flipped over. So it's been flipped over, it's been stretched, it's been moved horizontally, and it's been moved vertically. And these are the things that you can see. But so if you were to take the basic parent function approximations to it, then you would end up with this function g. Number 7, we want to find a composition of two functions. So we've got f of x is 2x squared, and g of x is square root of 4 minus x. And we want to find f composition g of x. And that just means we're going to find f of g of x. We're going to input into the into f g of x. So the square root of 4 minus x is going to go in here. So it's going to be 2 times the square root of 4 minus x squared. So we're going to get that. So notice we input into f g of x. So g of x, which is this, goes in here, which means it goes in here. And we get this. This is our 2x, our input, squared. And so, we can do a little bit of work to this because you got a square root being squared, so that gets rid of the radical. So you just end up with 2 times 4 minus x. Because the square root of 4 minus x squared is just going to be 4 minus x. And, that would be 8 minus 2x, distributive property. So 8, we're looking for an inverse function. We're given the function f that's x cubed minus 8, but we want f inverse. And the way you can do this is replace your f of x with y, and then swap the x and the y. So let's put the x where the y is, and the y where the x is, and now let's solve this for y. So to solve this for y, the first thing we would do is add 8 to both sides. So you get x plus 8 is equal to y cubed. And then take the cube root of both sides. And on the right-hand side, the cube root of y cubed would just be y. And over here we have the cube root of x plus 8. And so this is our inverse function. So f inverse of x would be the cube root of x plus 8. 9, you were just looking to determine whether or not the graph that was given was a graph of a one-to-one function. And you can apply the vertical line test. Remember, the horizontal line test will let you know whether it's a function. Of course, our graph looks something like this. And it clearly is a function because a vertical line can only hit that graph in one spot. But notice it does not pass the horizontal line test because you can draw a horizontal line that will hit the graph in more than one place. And so the fact that it failed the vertical line test tells us that it's not a one-to-one function. And then the last one, we were going to show algebraically that these are inverse functions. So one of the functions is 2x plus 1. The other function is x minus 1 over 2. Now, to show it algebraically, what we want to show is that f of g of x just turns out to be x, and that g of f of x also just turns out to be x. Both of those things happen, and we've shown algebraically that these are, in fact, inverse functions. So let's do this one first. F of g of x is going to be f of x minus 1 over 2. And notice this function...
Any juniors who would like a ticket for Friday can come this time. Thanks.
Notice this function just takes the input and doubles it and then adds 1. So I'm going to take and double this and then add 1. And now we just need to work this out. So first thing I notice is these 2's cancel. When you multiply, one's in the numerator, one's in the denominator. So you just get x minus 1 plus 1. And of course, that just simplifies to x. So we've shown that f of g of x does work out to be x. Now, let's see what happens if we do g of f of x. So it's going to be g of 2x plus 1. So in other words, it's going to be 2x plus 1 minus 1 over 2. And that numerator works out to be just 2x over 2. And of course the 2's cancel and you get x. So we've shown algebraically that those are inverse functions.